And now we have type 2 LSA. Here. It is OSPF type 2 LSA is also known as network LSA. Here. And type 2 LSA is generated for multi-access network types. Why? Because if you have observed on serial links, both routers are generating type 1 LSA, and they are telling that one it has a stub network where they are telling subnet mask and everything information about this link, and other thing they are telling it as a point-to-point link. In overall, what is this network, who is the neighbor connected on this network, what type of network it is, all the area is able to understand it. But if it is a network like this where a DR is connected, or else let us take a scenario like this. We are having a switch and we are having multi-access network. On a single interface, we can able to access multiple devices, multi-access network. In such type of scenarios, we need type 2 LSA to be generated. And type 2 LSA is required for OSPF to properly map all the connected routers to a single multi-access network like LAN. Here, everyone was mentioning 12.0.0.1 is my DR. And let us think he is our DR 12.0.0.1. He generated an LSA, he generated an LSA, he also generated an LSA, even DR has also generated an LSA. Clear? Type 1 LSA. Right? But these all routers with this type 1 LSA, they are able to understand that yes, we are connected, we all are connected through 12 network on this interface. But what is the network ID of this network? What is the subnet mask? Who will tell this information? As I told you, DR will tell it. How will he tell it? For that information, he will generate a type 2 LSA, which we call it as network LSA. Here, he will generate a type 2 LSA saying that what is this network ID, what is its subnet mask. And generation of type 2 LSA depends on existence of a DR. Clear? Usually on multi-access network, you will be having a DR at any cost. If you are not having DR, and if it is a point-to-point link, then you will be having it as a point-to-point. And some OSPF network types require a designated router, and the network types tells the router interface whether a DR should be elected or not. Why some OSPF network types require a DR? Because if we take this scenario, first thing is Similar to EIGRP, if you are going for EIGRP, in such type of scenario, how many neighborships should I form? Each router should have 3 neighborships. I'm writing it in reading. Sorry, greening. 2, 3, 4, 5, and 6. 6 neighborships overall, but every router has 3 neighborships. For 3 neighborships, 3 updates. Here, if I am having 100 routers, how many neighborships should I form and how many updates should I send? It is a burden on my router. Here, in order to reduce this, OSPF has got the concept designated router. And what does they do? I'm writing it in the blue ink. These routers themselves, they will elect one DR. Let us think he is our DR. Once the DR is elected, every router will send that network information to DR. And in turn, DR, whatever the information is receiving from R2, he will give it to R3 and R4, R4, R2 and R3, R3, R4 and R2. By this, what happened? These routers, they don't need to exchange the information to remaining 2 routers. They'll just forward it to DR. That's it. Clear? Now the processing is reduced. Right? So in such type of scenarios, we will use designated routers. And we will be using DRs only on multi-access networks. If it is point to point, obviously, I will be having only a single router on the other end. I can form the neighborship, and obviously I need to get the updates, and I need to send the updates to point link. So there is no point of using DR here. We'll be using it only on the multi-access networks and broadcast networks. Clear? But the thing is, how this DR will know, or these routers will know that we should elect a DR on this network? How? That will be dependent on the layer 2 encapsulation you are using. If you are using SDLC or PPP, it will understand that this is a point to point, so it will not elect DR. But if you are using Ethernet encapsulation or ARPA, router will understand, yes, I can this interface. There is a possibility that I will be connected to multiple devices. So I will elect DR on this. Clear? Multiple devices can be existing on this network. So I will elect DR. So the network type tells the router's interface whether a DR should be elected or not. And how a DR is elected? OSPF uses DR for 2 purposes. One is to create and flood a type 2 network LSA for that subnet on which they are connected. And the other is to aid in the detailed process of database exchange over the subnets, for the detailed information exchange in the network. How can we OSPF elects a DR and BDR? based on information in the OSPF hello packets. Whatever the OSPF hello packets the router receives, it will check what are the values that is needed to elect the routing DR. One is priority and the other is route ID. Here, priority and the route ID. Hello packet list each router's route ID and priority value. As I told you already, I shown you in the morning also. And how the elections takes place? Routers use the following election rules to elect a DR. And what are those? First, choose a router with highest priority value. If my value is 10, I'll send my priority value 10 in my hello. Default is 1 and maximum you can configure is 255, and the router with the highest priority will win the race. Yeah. Huh? Yes. Minimum it is 0, but default value is 1. And if priority is tied, choose the router with highest router ID. Here, and choose a BDR based on the next best priority, or if a tie, next best highest router ID. Once the DR is selected, then they will go for BDR, backup designated router. Clear? To change the default priority value on an interface, you can use IP OSPF priority value. Okay, this will change your priority value, and where you have to configure it on the interface command. And remember, DR always it is not a router, but it is the interface role. Okay, if I take a scenario like this, this is area 0 or something area 1 here, and the other end of the router 2. Area 1, area 0. Our R2 interface F0 by 0 is having highest priority in area 1. Then who is a DR? It is not this R2, but the interface. This interface is the DR value. DR. Okay. Why? Because the same R2 in area 0, it is not the DR. Clear? So remember, always OSPF and OSPF rules are always dependent on the interface. It is not on the routers. Clear? So you have to configure this. If you want to make your router, if you want to make this router as a DR for area 1, you have to configure priority not on the router, but you have to configure on that interface which is connected to area 1. If you want to make it for area 0 also, you have to configure it on area 0's interface. That is why here you have to configure priority on this IP OSPF priority value. Now, what happens when DR fails or BDR fails, or if a new OSPF neighbor comes up with higher priority on a LAN where there is already a DR and BDR. Nothing happens. When a DR fails, immediate backup you have BDR. Who is the current BDR? He will become the new DR. And remember, once a DR is elected and BDR is elected, no DR elections will take place. Always a BDR will become the DR. Now the elections will be keep on happening for the BDR. If the DR and BDR have been elected, now a new OSPF neighbor with higher priority has come into the picture. He cannot take over the DR or BDR role until the DR or BDR fails. What is he trying to tell you is, now our R1 we have made DR. Okay. R2, R3, R4. And let us think his priority is 10 and his route ID is 1.1.1.1. After this DR is elected, now R2 is our BDR. Now we have got one new router whose router ID is 10.10.10.10 and his priority is 100. Now already DR is a R1. He is elected. Now this R10's priority or route ID will not work. It has to be a normal DR other. Okay. Once the DR is elected and BDR is elected, whatever your priority could be, whatever your route ID could be, you are DR other. Once this DR and BDR has gone down, then only this router will become either the BDR or DR. Why? Because until then there will be no elections. Clear? And if you remember, when I have shown you, when I have given this command show IP OSPF interface, you have seen hello timer, dead timer, and beside of this dead timer you also had one timer called wait timer. Okay, how actually elections happen is, if you have configured some in our topology, you have configured OSPF on R1. Now R2 and R3 are also there in the picture in our topology. First you have configured R1. Clear? Our R1 will first, every router itself will declare himself as DR. First you have configured on this router, he will be telling himself as an DR. Okay, and now he will wait for that wait timer, whether it is 40 seconds or 20 seconds. By default it is 40 seconds. He will wait for wait timer. Within this wait timer, if any router has sent hellos to this router for DR elections, then only it will participate in DR elections. If any router after 40 seconds has sent hellos to this router, he will tell that your time is up, you are out of elections. I have waited for 40 seconds, now I am the DR. That's it. Here, so this is that wait timer. Clear? So no neighbor, whatever, if a new neighbor has come with highest priority and route ID, he will not become the DR and BDR until this router fails. The DR's interface IP address is used as a LSID for type 2 LSA. When a DR is generating type 2 LSA, when he is generating type 2 LSA, In type 1 LSA, LSID was router ID, and even advertisement router ID is also router ID. But in the type 2 LSA, LSID is DR's interface that is connected to that area, or the interface which is DR. DR interface IP, and advertisement ID is DR router ID. Clear? And what is type 2 LSA? It lists router IDs of the OSPF neighbors connected or attached to that multi-access network. In type 2 LSA, router along with LSID, advertisement ID, subnet mask, subnet ID, it will also list all the neighbors on that particular interface. By this, what happens? If any router doesn't know any of the neighbors, he will make a note. Oh, how many neighbors I am connected to? He will have a complete map. In this area, he is a DR. He is telling that he is connected to this many number of neighbors. He will cross check. Oh, am I also connected with all those neighbors? Okay. And you have to check the type 2 LSA net link state. This is the name of type 2 LSAs in OSPF database. And if you want to check for particular DR, then you have to mention the DR network ID, router ID here for detailed outputs. So see if we go into our topology. This is type 1 LSA, router LSA. This is network link states, which states that this is a type 2 LSA. For which area? Area 1. (12.2), which is the DR interface IP. Advertisement router is DR router ID. Network, and here you can see (12.2). Advertisement router ID is 23.2. Who is the attached router on this? 23.2. And what is the network mask of that? /24. Here on this router 23.2 and 1.1.1.1 are existing. Clear? And you can see here it is a subnet mask. Any doubts? And this is the point of, this is the R1's point of view. If you see on R2, who is a DR, database, network, and here if you see for 20 on DR, here also we are having the same entry. Type 2 LSA, DR interface IP, advertisement router ID is DR router ID, his subnet mask, and were all the routers connected on that particular network. Clear? And this is for area 2. On area 2, clear? That's it. Yep. And now will we speak about type 3 LSA. Remember type 3 LSA, OSPF uses the concept of areas to reduce memory and compute resources consumption. That is why I told you, if we are connecting all the routers in a single area, if one link is down, all the routers has to process the router 1 LSA. In order to avoid that, we will use areas. And ABRs are used to connect different OSPF areas together. Obviously, you know this. Remember, type 1 and type 2 LSAs are not advertised from one area into another area. Okay, obviously, if you are doing, if the ABR is sending one area router 1 router 2 LSAs, sorry, type 1 type 2 LSAs into another area, what is the purpose of doing areas? The purpose of doing areas is to not to make all the routers know complete information. It has to know only the brief information, right? For that reason, type 1 and type 2 LSAs are not advertised from one area to another area. If type 1 and type 2 LSAs are not moving from one area to another area, let us think is a 10. Clear? So this is area 1 and this is area 10. Sorry, area 0. Clear? Just now we have seen that ABR has no permissions to allow area once type 1 and type 2 LSS into another area. Clear? But router 10 has built these networks 1.1.1.1, 2.2.2.2, 3.3.3.3. Information is linked state database. Clear? He cannot forward that information into area 0 by type 1 and type 2 LSS. Why? Because type 1 and type 2 LSS can never move from one area to another area. No inter-area communication. Now, how will these networks 1.1.1.1, 2.2.2.2, 3.3.3.3 will be known to another area? And how another area routing information will be known to this area? Here, for in order to save processing power, we are restricting type 1 and type 2 LSS. But we have got a problem. There is no communication between area 1 and area 0. How to get the reachability? For that reason, we have got one extra LSA. Only the ABR has got that power to generate type 3 LSA, and that LSA we call it as type 3 LSA, and that also called as network summary LSA. Here, where in this network summary LSA, he will create summary of these type 1 and type 2 LSAs, and he will advertise that in network summary LSA. But when he is sending this information into another area, till now he has information that if he wants to reach 1.1.1.1, he knows he has to reach R1. For 2.2.2.2, he has to reach R2. For 3.3.3.3, he has to reach R3. But when he is giving the same information into another area, he will not tell that this 1, 2, 3 routers information. Why? Because their type 1 and type 2 LSS cannot enter into another area. So they will never know who are all these R1, R2, R3. Now they only know this ABR. So what will he do? He will tell that if you want to reach 1.1.1.1, reach this interface. If you want to reach 2.2.2.2, reach this interface. If you want to reach 3.3.3.3, reach this interface. If you reach me, I will make your content go to that particular network. From then on, I will take responsibility. Clear? But along with this, he will also mention the cost for him to reach this particular networks. Whatever the cost he has, for suppose he needs cost 10 to reach all the networks, he will also tell that I am having cost 10 to reach them in the type 3 LS. Clear? Clear? So this is all about the type 3 LSA. Yeah, so type 1 and type 2 are not advertised from one area into another via ABR. So not advertising type 1 and type 2 LSS across areas saves memory and reduces the complexity for each run of the OSPF algorithm. But the problem is they will be isolated from the network of different areas. So ABR generates a type 3 LSA for each subnet in an area and advertises each type 3 LSA into another area. Clear? And you can see type 3 LSA does not contain all the detailed information, topology information, and it is created by ABR. It consists of each subnet and a cost to reach that subnet from that ABR. Clear? if he is a ABR, if he is costing some 10 to reach all these networks, in his type 3 LSA, he will send, if you guys want to reach so and so network, my cost is 10. My cost is 10. Now what do? You have to calculate your cost to reach me plus my cost to reach that particular network. Understood? Yeah. And it summarizes the information from type 1 and type 2 LSAs, and it is also called as network summary LSA. Type 3 LSAs appear to be another subnet connected to the ABR that created and advertised the type 3 LSA. Now this area 1 networks are advertised into area 0 by this ABR. Now all these routers in this area 0, they will think that these networks from in the type 3 LSA are directly connected to this particular router. Why? Because they don't know how the networks behind it they are connected. They only knows this ABR. That is why I told you OSPF will behave like distance vector between the areas, different areas. In a single area, it will act as a link state. The ABR assigns an LSID of the subnet number being advertised. LSID of the LSA will be the network ID that he is advertising, and advertisement router ID will be self router ID of the ABR. Clear? So that is why red networks routers in another area will think that if I want to reach this network, I have to reach this particular router. Clear? And ABR also adds its own router ID in the LSA because multiple ABRs can advertise the same subnet with the same LSID. When multiple areas, when multiple ABRs are there and all of them are advertising the same network, then routers will be confused. To identify, they will use this own router ID as an advertisement router ID. Clear? And if you want to check type 3 LSAs, they will be in the list of summary network link state L states. And how can you see it? Again, the same command show IP OSPF database. If you want to be clear, detailed information, give summary. And what is the router ID? Clear? I am removing this. And if you see here immediately, there is no network information of 1.1.1.1, and on R1 there is no information of 3.3.3.3. Here Yeah. According to our topology, area 1, area 2. Clear? R2 is having interfaces in multiple areas. Clear? But he has no interface in area 0. That is why whatever the loopback here we are having on R3, it is available on R2, but R2 cannot forward it to the R1. Similarly, whatever the loopback it has, R1 has, it is reachable only to R2 but not to R3. Why? Because who has got that access to generate type 3 LSA? Only ABR. In order to become ABR, what is R2 is lacking? It doesn't have any interface in area 0. So that is why it is not able to give this information to different routers. Here. Now what will I do? I will create a loopback and I will advertise that in area 0. And we'll see the difference. Is there any network summary LSS here? No. Area 0. And if you immediately show IP OSPF database, summary network LSS for area 1, for area 2, and even for area 0 also. When will a router can generate summary network LSA, that is type 3 LSA, when it is an ABR? Yeah. It has got 4 interfaces. Out of this, loopback 1 is in area 0, 2 interfaces in area 1, and 1 interface in area 2. By this, it has become ABR. In area 0, what are the link IDs advertised? 1.1.1.1, 3, 12, 21, and 23. These networks are advertised into area 0, who is via home 23.2. If you go and check in area 1, 2, 3, 23. These are advertised into area 1 via home 23.2. In area 2, 1, 2, 12, 21. Advertisement route ready 23. Summary. Wait. For area 0, it is telling that 1.1.1.1 23.2, subnet mask 32, metric is 11. If you want to go to 3.3.3.3, reach 23.2, subnet mask 32. If you want to go to 12 network, reach 23.2, subnet mask is 24. What is my metric? 10. For 21 network also, along with this, it is including 23 network where area 0 don't. Here, you see this is some number. Here, the main difference here is, here you will not be having any detailed information as if you have in router LSA or type 2 LSA. If you see this 3.3.3.3 in router LSA for area 2, okay, compare the difference. Here what else, what do you have in this? Here just you are having network and whom to reach, that's it. And what is it? Subnet mask, right? But let me open the router LSA, OSPF database router from 3.3.3.3. Network, what is a metric, what is the type of the network. If I want to reach this network, whom should I reach? 3.3.3.3. Clear? But whereas in type 3 LSA, this thing subnet mask, whom should I reach? 23.2. That's it. By this, what happened? 2.2.2.2, it will never know that this 3.3.3.3 is actually connected to this router ID 3.3.3.2. Right? You'll only know that it is actually connected to 23.2. That's it. This is the difference. Non R1 show IP OSPF database. No, sorry, summary. And you can see the detailed information. Everything same. 23 network reach 23.2. 23 3.3.3.3 reach 23.2. 2.2.2.2 reach 23.2. And if I go and type this show IP route, IA. IA means that this is not our area network. It is from some other network. Here, then how will our router calculate this metric? Whatever the metric that type 3 LSA has given, to that it will add this router's cost to reach ABR, and it is 11. OS 110 is the AD value, and from where did it land? From OSPF. So IA means that inter area. OSPF inter area. Here. OSPF. Yeah. If you want to see who are the border routers, show IP OSPF border routers. This will show you who is your ABR. I means intra area. I means inter area. 23.2 via 12.2. 23.2 is my ABR router ID, and how can I reach him? with the IP 12.2. If I want to reach him, who is interface I have connected is 0 by 0. What is its role? ABR. In what area? Area 1. Detail. And is also giving the same thing. Some flags. Clear? Yeah, and how do you check show IP OSPF? No. Interface. Detail. E 0 by 0. Detail. And if you see here, how can I know who is DR and BDR? That can be listed in the show IP OSPF interface. If you see this output, what is the address of us? 12.1. And where is this advertised? In area 1. It is process ID is 12. And what is our route ID? 1.1.1.1. And what is our network type? It is broadcast. What is its cost? Its cost is 10. And if you see here, what is our state? BDR. Our state is BDR. And what is our priority? Priority is 1. Now who is the DR? 23.2. Who is the BDR? 1.1.1.1. We want to go to 23.2. What is your IP connected? 12.2. 12.1 is your interface IP. Hello, dead, wait. Already you know this. And neighbor count on this interface. Neighbor count is 1. Adjacent is only 1. But if you are having multiple like this, then here you will be having neighbor count as 1. Sorry, adjacent count as 1. Neighbor count as 3. Why? Because you will be forming the adjacency with only one router. Here, yeah, the same thing. Here also the same thing. Neighbor count is 1. Adjacency is with 1. Who is the DR? 23.2. Who is the BDR? 1.1.1.1. And adjacent with whom? With BDR. Clear? This will show you all the area 0. It is a backbone area. Number of interfaces in this area, only 1. Area has no authentication. And how many times SPF, when was the SPF last time executed? Area ranges number of LSAs only 6. And remaining stuff you will be learning later on. In area 1 we are having only 2 links and all the same stuff. Yeah. So like this, you can verify area OSPF. Channelings no, statistics no, topology info. That's it, brief. Okay, so this is all about the type 3 LSA. Clear? And now we have limiting LSAs. Okay, see actually what happens by default, our routers, they will have no limit, like how many LSAs can it learn. Clear? But as the LSS count goes on, as it goes on increasing, our routers will have problem with convergence and memory. If it is having more than number of LSS, convergence will be that slow, and the memory will also be consuming, right? And if you think that you have to limit your LSS that our router learns, then you can, to limit the number of LSS, use the command maximum LSA and the number. How many LSS can our router learn? Okay. When the router learns, yeah, you can give it. See, you are sending me the LSS. I can limit myself. My network admin can tell me, yes, you have to learn only one LSS or two LSS, three LSS.
Is giving them for router or
on the router?
That I mean, in the router have his own LSS.
He will be having his own LSS type 1, type 2.
Have a limited one. I mean, 10 LSS or 12.
By default, he has no limit.
No limit.
By default, you can see read this first bullet point. Yeah. By default, there is no upper limit for the number of LSS that a router can learn. But you can limit it. How can you limit it? With the command max LSA number. And when the router learns more LSS than the configured value, it generates an initial log message. First, it will generate some initial log message. As the time goes on, router waits for a period of time, after which it repeats the warning or log. If you keep on generating the log, hey bro, you have told me to learn only one log, one LSA, but I am learning more than that. After some iterations, periodic iterations, it will break the neighborship. Clear? On R1, well, yeah, max LSA, you can give it from 1 to 4.29 billions. Let me give it as 2. Threshold for maximum number of nonce has been reached, OSPF 12, 1 LSS. Maximum number of non-self generated LSS has been exceeded, 5 LSS. And this will be going on for a few iterations, and after that it will be breaking the neighborhood. Clear? This is how it does the thing. Clear? And you can see here, as soon as I have changed the configuration, it has broke down the neighborship and it has formed the neighborship once again, such that it can learn all the LSS. Right? Yeah. The last topic for today, OSPF database exchange. Okay. Every router within an area should have an identical copy of LSDB. If you and me are in the same area, we should have the same identical LSDBs databases. Okay. Internal routers have only that areas type 1 and type 2 LSS. If I am in area 1 and you are also in the same area 1, we both will have only type 1 and type 2 LSS. Okay. But if you are having ABRs, then ABRs will have type 1 and type 2 LSS of different multiple areas. And what does OSPF do? OSPF routers flood type 1 and type 2 LSAs they created and learned from their neighbors. What happens is whatever the type 1 LSA I have learned from my neighbor, I will give that as is to you. So like this, whatever type 1 LSA I have generated, I will give it to you along with the neighbor, with the LSAs I have learned from my neighbors. And OSPF defines several messages, processes, and neighbor states that indicate the progress when flooding the LSA to each neighbor. And to understand the detailed topology exchange process, you should first understand the OSPF message types and neighbor states. Clear? And this database exchange in detail we will be discussing tomorrow. Clear? What are these OSPF messages? What are these neighbor states? Clear? And we'll be continuing from tomorrow. Clear? It's up for today.